Welcome everyone. My name is Shahzad Masud. Welcome to Microsoft 365 Virtual Marathon. I'm going to present today the topic of serverless Kubernetes, KEDA, and Azure Functions. And uh, please do share yourself. Please mark your calendars for the collaboration that is going to happen next year at the Grand Resort. And please do also do that. And thank you for all the sponsors that are actually working with this conference. And they're actually the heartline. I mean, you can say that they are the actual guys behind all this effort, and I really like to uh, thank all of them. So let me introduce myself. First of all, my name is Shahzad Masud. I am a certified enterprise architect and cloud professional. I'm a principal technologist working at NetSol Technologies. My main responsibilities include uh, enterprise architecture, cloud scalability, migration, and uh, checking the legacy products and other stuff. One of the recent things which one of the recent accomplishment which I have done is migration of a legacy product in all three different flavors of AA. That is software as a service, product as a service, and infrastructure as a service. So I actually helped my team accomplish that one, and that is something which was very exciting. It's a long 4 years journey in my current company, and it actually gives me lots of lesson learned and experiences which helps me in my current career and other stuff. And Kubernetes and Dockers and containerization was an important piece of the puzzle, and which actually helps me move around a lot inside the enterprise space, in the product space, in the software as a service space, also as in the space of infrastructure as a service. So I really appreciate everyone who actually started to learning in this space and who actually want to proceed further in this one. I'm from Lahore, Pakistan, and that is really an exciting part to be part of this one. And I'm one of very few guys actually participating from here. There is a raffle as well on all the online sessions, which you can also contribute to that. And there are some heroes who are working with us in this COVID situation where we are not presenting live to you, but in person to you, but we are actually helping online, and we are actually delivering all the things in an online fashion. Uh, Here is a small roadmap of the things that we will be following through. I'll be actually walking you through from different perspectives, different areas of what is the containerization, what is Kubernetes, how the Azure function and server capabilities are being done, what are the KEDA functions, and we'll actually be looking at some of the questions and answers at the end of the day. I would be really appreciate if you give me feedback on the event, on myself, whatever, on all the things whatever we will be discussing this session, and that will really help me arrange and align for the next session, which I am going to plan, and it will really help us proceed further. Uh, there's a little bit about everyone, which I would be assuming, and I have formed my session based on a few things which I am actually uh, taking as an assumption. You may say that, but that is if you are starting to learn container, or you are in the middle of learning containers, Docker and Kubernetes, this session will be very helpful to you. If you are in a process of migrating from a legacy application or a normal application or a modern application to containerization application of your application, then this session will be very helpful to you. If you are already doing a microservice based architecture in a Kubernetes, but you are actually stuck inside the VMs and other stuff, and you wanted to get out of those VMs. You want to get out of the scalability challenges. You want to help. Uh, you want to get help on different other things. This session is really helpful for you. If you are moving to cloud and you are gathering your resources, you are warmly gathering your resources, you are trying to use different cloud providers, especially Azure, and you're finding it difficult that it's not as good as it is, but it's the recipe to success is not using the virtual machines, rather your recipe to success and to agility and to performance and to everything other than that is actually based on uh, how you use the application, how you go serverless. Your application is actually working, but you don't have any users at a specific time, and you're actually consuming your resources. So how to go serverless on that part, and you only pay as you use the cloud platform. You are handling lots of users, and suddenly there's a big rise and surge in all of your users, and you want to move from one virtual machine to like 100 virtual machines. This session will actually help you in reducing the cost and other things like the virtual machine from a complete OS oriented part to a process oriented or a Docker oriented part. So that really helps you with that one. So this is something which will really help you move along with most of the things that are really helpful in this space. And last but not the least, if you have been learning Dockers and Kubernetes for a while, and you don't think so that you have some questions that need answers, and you're still looking for those answers, and you don't find anyone to actually give you answers of those questions, then this session is definitely help to definitely for you guys to actually ask the questions, ask and get the answers of those questions. But again, we have a limited time availability, and if I cannot answer all of the questions, I'll definitely leave my information so you can always contact me. So these are the basics. These are the basic assumptions which I actually took while actually designing the whole presentations. And so if you are in either of them, then this is the right place. You are in the right place. So let's start with a little bit of basics and. Uh, what about the containers and Dockers and where they originated, how they originated, how the container actually works, and how things are actually in the real place, and how we can work along with those ones. Containers are actually different processes, isolated processes running in a larger machine. So if we talk about a uh, legacy arrangement about different applications, what it has is it has a underlying host, underlying hardware. That hardware actually contains different hypervisors. Those hypervisors actually helps us with different guest OSs. Then those guest OSs actually then have some libraries, dependencies. Most of the things actually are uh, based on the stuff that people like OS upgrades, then library upgrades, then binary upgrades. Those upgrades are always painful. Then you put your app on top of that, and those apps normally actually behave differently in a different environment. Like they actually behave different in a Windows environment. They actually behave in Linux environment. They actually behave differently in another OS, another guest OS, another library, another set of libraries. They actually behave in a different way. But the developer actually keeps on saying that if you run this application in uh, the prescribed one in the prescribed amount of the libraries, then you will be able to get good response on that one. But most of the time, people actually ignore that, and they keep on complaining about the problems that this thing is not working, this is not working, so and stuff like that. So there comes the containers rule. The container are actually simple processes. Those simple processes are actually the heart and core of everything. There is a big machine available. That machine actually hosts normal hardwares. That hardware is of a very higher magnitude, and there is a container engine running on top of it. Container engine actually take all the information from its available core, its available binaries from there, and the application that we have developed is bundled with all the optimum libraries and binaries that are available for our particular app. So if we use the optimized version of that application along with its binaries, the application performance will be truly awesome. But if we are actually using the binaries which are not for that purpose, so that will not perform as good as they should be performing. So our app will perform a lot better in a containerized environment rather than a virtual environment. The second portion or second part, which it will actually perform a lot better because we are using optimum libraries, we are not using non-optimum ones. The third one, which this will actually work a lot better, is that we don't need more physical hardwares, but we can actually spin up a new container instance from the same hardware that we are using from the cloud. So that means if we need to scale our application up, so we can scale it up like very quickly. We can spin up a new instance within a matter of seconds or at the max a minute time, and we'll be able to actually go over multiple things and our application will be like that. Fourth benefit is actually one of my favorite, that it will give us a liberty to actually to have multiple versions of the same application in multiple environment as well. Like if you want to deploy your application in a VM environment, it will always remain a challenge to actually shut down a VM, deploy the app, and then make it online. That's called maintenance mode. So we have to turn on the maintenance mode for all the deployments. But in container mode, most of the time it is a blue-green deployment. So all the deployment part is actually run in a blue-green mode, and it's more like a zero downtime mode. So these are the four main major advantages that are there for everyone to actually look into that one. Uh, is this a new concept for us? Actually, this is not a new concept. Containers are actually available long before Docker actually come into place. There are few runtime initiatives that are available before that one, but as the Docker actually revolutionized the whole container thing by embedding different operating systems, by portability, by agility, or for different platforms. So that is one of the reasons that uh, actual definition of a container actually come into existence after the Docker actually launched this platform with a big blue whale. That concept actually revolutionized itself. There are many open source initiatives as well, like runtime spec and image spec that were already in open source place already available, and whenever we want to use that, we can use them as per our need. How actually this thing work? Like we connect to that Docker container, or we deploy our application? Actually, that's not. We actually there are some certain processes that you create a complete application repository that is called image, and you place it at a publicly accessible location from where you pull that repository on that particular uh, container image that spins up itself, pull all the resources from the main hub, and you can start using that. There are multiple ways to actually spin up, or there are multiple ways to actually use this one. Is there you can use it on a public sector as well, and you can use that on a private scale as well. What do we mean by that? By the public and private scale? Uh, by public scale, we mean that we can have it hosted. We can have hosted the images on a public hosted service as well, like GitHub. We can use GitHub as well. We can use Docker Hub as well. We can use container registry as well. We can use other uh, uh, cloud providers registries as well. Uh, or we can use a private one as well. So you can set up a private registry, you can set up the same on the public registry as well. So public registries also give you sense of private registries as well. Like Docker Hub can actually give you the images in a private mode as well as it can give you in a public mode as well. So we can use both the registries. What we do is we actually bundle up our whole applications in repositories and bundle up that file, create the image file, upload that file, and then pull up that image information from the respective registries, and that container is up. So, so this is a brief introduction of what actually a container is and how the container actually works. So, if I actually go into the details of the container, how the container is set up, how the image is set up, how other things are set up, how to form an image, load an image, transform an image. That would really take around 2, 3, 4 hours to actually get through that. But as we have limited time available, so we'll be actually covering that one as a overview only. So I have given a few links for resources. These are the resources which will give you a practical perspective, a overall perspective, a detailed perspective, and an interactive based scenario as well. So there is the first one is what is a container. This is by Liz Rice, and the second one is you containerize your app with Docker and Kubernetes. That is Dr. Gabriel and Schenker. And the last one, which is one of my favorites for all the people who are actually starting understanding the Kubernetes and Dockers. So learn Docker and containers using interactive browser-based scenarios where you can actually work through that part. So you can check on this one, and we can go through that part very quickly. And if there are any questions on that, I'll be happy to answer them in the question and answer session. Let's go to the Kubernetes part. Kubernetes is actually a clustering technology for container host. One of the problems that containers actually get is the scalability, deployment, health, provide the ability, load balancing, life cycle of the container, network and communication, which container is going to in, what container is going to out. This whole paradigm or this whole equation is actually described to everyone as the orchestration part. There are multiple orchestrators available in industry, in the open source world, as well as it is available uh, in the corporate world, in public clouds. So these orchestrators are actually helping us to formalize our high availability strategies, our load balancing strategies, our life cycle strategies, our deployment strategies, our container strategies, our debugging strategies, our fault tolerance strategies, our cluster management strategies, our managing the spike strategy, or streamlining the communication strategies. So these orchestrations, the top of the line, which is in my point of view, is Kubernetes. Kubernetes actually helps us with almost all the things that are required for the container orchestration. It's like you can say a magic wand for our ship actually. So you can lean to left or right to understand how things are working using Kubernetes. It actually helps you not only with the virtual machines, not only with the containers. It helps you with many other things. Like it can help you schedule different jobs as well. You can schedule different jobs. If there are any containers which are faulty, they require a restart, or maybe they require an image upgrade, or maybe they require a discovery, maybe they require a bit of a load balancing, maybe they require anything that is much more required for the health of an application. It actually helps you with that. Uh, there are all these things are uh, more like our thoughts and our words and our scripts which are working in Kubernetes. One of the favorite parts in Kubernetes is like service discovery and load balancer. As the modern world is more towards moving to microservices architecture, so microservices architecture is all about having different service discoveries, different load balancing, lower load balancing on a service which is not that highly scalable, but higher service discovery on uh, a place where you require a lot more agility, a lot more users available on that part. So from a service discovery and load balancing point of view, Kubernetes gives you a lot more templates and uh, and other things, so you can do that part. So in the older world, in container world, in older world, most of the people are actually thinking in terms of a vertical load balancing. My machines are actually reaches capacity. Let's increase the core. Let's increase the RAM. Let's increase the network capacity. Let's increase everything in virtually. But along with the inclusion of the public clouds, we actually go with the horizontal scalability of the same type of resources, but with the inclusion of containers, we can actually go with the horizontal scalability in a two-dimensional way as well. Like we can go with the horizontal scalability as well as we can go with the vertical scalability, as well as we can go with the third dimension of scalability that we wanted to scale certain services at a very high level and certain services at a very low level. So as the world is actually moving from 1D to 2D to 3D and 4D and so on, so that's where this piece of the puzzle is actually moving in the same direction. The next highest pain point is the automatic rollouts and rollbacks, which is the mostly the pain point in a highly scalable environment. You actually turning on the maintenance mode. You're actually turning on different downtime strategies, and those downtime strategies are actually very painful for the people. And there are full-fledged teams that are handling, and people are actually spending nights and weekends in some cases to roll out the application changes, roll out their effort they have done for the few sprints, and roll out the features in production. So containerization and orchestrations champion Kubernetes actually helps us with the automated rollouts and rollbacks, and that really helps us with this one. Volume management is like space discovery, and space things are really key factors where you have isolated space available. You always find it very difficult to actually merge logs. You get the debug output, get the file output. You wanted to take out some images, you want to do some processing, you wanted to have some workflow. Volume management or disk management is an important piece of the puzzle. So in this Kubernetes scenario, it really do help you with a global volume that can be attached to all the nodes, all the pods, all the configuration over there. And final, but one of the most important part is the security, secret information, and configuration management. You have to provide configuration management to all the pods, all the services, all the horizontal scalable uh, items in your place. So that is really a pain point. But if you are doing that using Kubernetes, and you're doing that using an orchestration tool, this will be a lot more easier. So what it actually does is it actually has a few things in its buckets. It has API server, it has controller manager, it has schedulers, in that it has etcd. Uh, there are all the other things are worker nodes, and there are Kubernetes master nodes. Kubernetes master nodes actually exposes all the APIs and all the controllers to outside world. And if the application has some scheduling capabilities as well, that scheduling capabilities will be used on spot too. So once we actually start our application, that application actually register as either the controller, or it actually register uh, as an API server. So either that is uh, our application as a microservice, or that is a web application. If that is a web application, so then in that case we actually need to get that application up and running. As soon as there is more load on the application, etcd actually uh, come into the action and inform the controller manager that we have less number of pods available. These pods actually auto grow itself to our configurable capacity, and that configurable capacity actually then inform us that hey, you have to increase your capacity to match the requirement by this application. If we have not set any upper bound, so it will go as max as it can as per the hardware limits. If we have set the upper bound, then it only goes up to that one and start throttling the application nodes and the application request. In that scenario, it will go a little bit excuse me, it will go a little bit on a lower part. These proxy elements are more like those elements which actually interact us as a write and read nodes. So proxy pods always help us with the horizontal scalability, and these worker nodes keeps on growing itself based on the uh, available resources, available requirement, available request count, and number of requests that are there. The common objects are for the Kubernetes are the pods, the deployment, service, and ingress. So ingress is actually managing the external access to the services, and the service is a layer that is set on the pods to expose them on the network. Deployment is basically done on all the pods, and pod is the basic execution unit. So these four things actually form the complete uh, uh, Kubernetes recipe. In this, you can create replica sets for the deployment on different pods and create different services for the ingress portion, and that ingress portion will be actually working with that one. You have done all your homework. You have built up a Kubernetes application. You're still not very sure that is it really the optimum part? Is it really the way that Kubernetes guys actually uh, recommend that you can get your conformance report as well from the GitHub. There is an open source initiative is available for K8s conformance where you can share your configuration, or you can download that one on your local machine as well, and you can also do that. There are lots of recommendations as well in there which can help you solve many problems: deployment, image creation, how to auto deploy. If you're not doing the auto deployment, auto configuration part, there are guidelines available on the conformance part as well, and you can do that by doing this stuff. This is just a feather in the cap. Most of the people actually like to be certified, so this is something which can easily be done. How you can use Kubernetes? You can actually download it for your desktop, Docker for desktop, and you can enable the Kubernetes platform. This Kubernetes will actually start with a free local implementation of a Kubernetes. This is a single node application, and in order to learn more, you can actually start it with a single cluster. So this single cluster would be a good starting point for you to learn more about the concept, and this will really help you do a local debugging or testing or anything like that. If you want to go over different other portions as well, like you want to go over to the cloud from the same system, you can also create uh, to some other Kubernetes stack as well by configuring inside a configure JSON as well. There are other options as well, like uh, public cloud Kubernetes as well. So we can go over that one. Here are some useful links for the Kubernetes, Dockers, and other stuff which we can not explore in a much more detail, but there are good tutorials available by James Quigley. Uh, that is on top microservices, Docker, and Kubernetes. That's a 55 minutes video which can cover a lot more than I can cover today to help you get started. There's if for people who actually learn, who actually likes to learn from the books, the learning path, Kubernetes learning path. That's also a very good ebook with a hands-on Kubernetes with videos and handbooks, hands-on and Deconstructed by Cass and Anderson, and that's the video as well, or how that works. The last part, the last one, Kubernetes Deconstructed, is like for the people who actually likes to know inside what is happening inside the virtual machine at the kernel level, how the kernel can be manipulated, and how you can actually contribute back to the Kubernetes. The last part, last link is actually for those people who are more interested in this. Azure Azure also helps us with the Kubernetes services. These Kubernetes services are like fully managed. All the people who are using Kubernetes, they most of the time they actually use command line interface, but thanks to Azure services, they are actually providing it as a fully managed service. This fully managed service actually helps you set up the master resources, worker nodes, pods, other resources, scalability, and also a conformant link as well on one page. So it's a one-stop shop. You can have your complete shopping list over here, and you can shop from Azure Kubernetes service, and that Azure Kubernetes service and can help you with most of the things. There are some good uh, resources on the Kubernetes and Microsoft Azure with the road ahead. There's a good video for which was presented last year in Build 2019. That's in November, somewhere in the last quarter. And if you want to learn more about the CLI and services and other stuff, I really like this one. This is a quick start. When I started learning Kubernetes like 4 or 5 years ago, this was one of the very good learning material that I get, and this is a complete workshop if you want to go hands-on with the Azure Kubernetes services. All three links are there to help you understand and go hands-on with more things, and they're actually very good. Uh, if we discuss about the container, if we discuss about the Kubernetes, and if we did not discuss about the Helm, that would be a little bit unfair to this awesome package manager. This package manager actually uh, install all the Kubernetes application, install all the dependencies, which actually helps us templating all the engines for our application. Let's say, for example, you're trying to build up a complete microservice application. There are two ways actually to do that. One way is actually you can start using a application.yml file, configuration.json, how to configure that, what are the network, what are the volumes, what are the other stuff. You have to take care of all the things yourself. The second option, which is an automated option, you start using the Helm packages. You include the package, microservice package or MySQL package or SQL Server package, NoSQL package, this package, and you just simply create different charts, and then start adding those charts and patterns inside the application, and you're good to go. So Helm is a package manager that helps you with all the containerized and Kubernetes enabled application. And one good thing about the Helm is it works with most of the Kubernetes service providers, Kubernetes service providers, public and private. And the most important part is that they are cross compatible as well. Like you can use the Helm inside your local machine as well, and you can use Helm as part of your uh, public cloud as well. So there are some good resources available for Helm, and we'll be using those patterns to understand. So in a summary, we have physical applications, we have physical application scalability. We can transform those physical applications into master and nodes, and they are automatic scalable. That gives you a better understanding, and it orchestrates containerized workload and services for all the resources and all the applications. Either it's a schedule, it's a cron job resources, schedule resources, distributed resources. Kubernetes actually helps you in all those things. So that's a bit of introduction of containerization and Kubernetes. Let's go with the Azure Virtual Node and Serverless. Virtual Node are uh, Let me go back a little bit. Like when you are running a container, you are actually running it all the time. So you don't need to shut it down. You don't need to uh, do anything. As soon as the users are there, it can scale up, it can scale down. But you know, there are a certain level of containers that are running and that are giving you, that are increasing the amount of money that you're spending. If one container is running, it is the meter is there. The taxi meter is actually running. So if you're in a public cloud, it will keep on charging you. Azure actually provides you with an additional capability of increased scalability on demand. Let's say, for example, you are anticipating is high workload on, let's say, Box Day, 26th of December. You are anticipating a high workload on your application on a special occasion, on a special marketing campaign, or on a special anything like that. So what you can do is you can actually provision a node as a warm up nodes, and those warm up nodes can be utilized, can be used for the application as a specific time. So in a virtual machine environment, you can create a virtual machine that will be spun up, added to the whole code, added to all the things, all the stuff within a specific amount of time. But virtual nodes are something which are up and running without a big downtime, without a big uptime or a downtime availability, and it will be available to you without that. So this capability, virtual nodes capability, is something which can run uh, even within 1 second as well. So this can run on the container, Azure container services as well, and you can run the code in there. So that means you only need to have your code available, and that code can run in the virtual node, and you can then use that virtual nodes to be available inside your application. And with that virtual nodes uh, is a proof of fast provisioning of your pods, and only a pay per second for the execution times. But in case of a complete container, that is not a pay per second, but it is actually pay per hour, and that is a very high one. You don't need a complete VM to compute nodes. You don't need to deploy anything. You don't need to do anything. It's a complete managed, scaled scenario where you can have different pods and you can have different visual uh, things available over there, and it's just running your code. So that means you don't need a pod to run the scenario. That means you don't need to run anything other than that, but just your code. So if your code actually runs for 50 milliseconds, you will be charged for 50 milliseconds. If your code runs for 1 second, you will be charged with 1 second only. So that's the beauty of this one. So that means it's hyper scalable, as well as it will only charge you for the use, and it will not bounce back any of the request that is being put towards this one. So virtual nodes are those nodes on this fast provisioning of your pods, and it can auto scale based on needs, and you can actually inform your master node that we can use virtual nodes to go serverless, and that will really help us. Virtual nodes. There are some quick guidelines available for on Microsoft side, and there's some very helpful functions on GitHub available, GitHub as well, and we can go over them. But due to shortage of time, I am just giving you an overview of what the serverless Azure functions are. Those Azure functions can go a lot more meaner, and these functions are a lot more better. So our Azure functions are small piece of code which runs with our other scenarios, and those are here to help us with an execution. Azure functions can be triggered with from anywhere. It can be triggered from any type of event. That can be in the form of a data, that can be in the form of message, that can be in the form of a schedule, or that can be in the form of a HTTP request as well. So let's say, for example, if you want to run a specific workflow and you're running your application inside a container, and you want to run I mean 3, 4 other triggers as well along with the application In past and legacy application, we have very limited choices and we have to set up the complete infrastructure, workflow infrastructure for that purpose. But over here, what we can do is we can actually schedule that one. Let's say, for example, if you are running a shopping cart or if you are running an application which is a workflow based on a queue application, whenever there is a new person comes in, add a particular discount to that, or add a particular mailing address to that, or add a particular verification to that. For example, in the fintech industry, if you are going for a finance solution, that finance solution requires a certain level of checks and balances on that particular lessee. So we actually use this triggering functions to help understand what the actual workflow of that function and how that is being manipulated. And it it runs on a schedule as well. It runs on an HTTP request as well. These Azure functions can be combined with many other things. Uh, these Azure functions can be written in any of your choice. It's not like if you're developing in C#, you are only allowed to use the workflow engine of a C#. So you can use these Azure function in any of your language. However, C# is one of my favorite language, but you can use Python, you can use JavaScript, Node.js, JavaScript, you can use Java as well. You can use a PowerShell script as well in order to run that. So this is kind of DevOps guys can also participate in this one and also start writing routines as well. So its pricing model is very simple, very lean. It's a pay-per-use pricing model. Security, definitely, whenever you are using OAuth services of any provider, you can use that, and these functions actually helps you integrate the security. There are public service providers as OAuth providers as well. We can integrate those as well. Um, these functions can also be hooked up along with the CI/CD part as well. Like you can hook up with them with the GitHub as well. You can hook up with them with Azure DevOps services, and there are many development tools that are also available with them. Uh, this one, I would definitely say that there are some limitations as well. These does not many of the Azure serverless functions do not support session management or state management. They are absolutely stateless, but the good news is that Azure functions are completely stateful and the stateful serverless architecture. So you can use the durable function category or the Azure function, and you can utilize the complete full power of the statefulness, just like any other application. These are completely open source. If you want to give a complete startup, and the startup is already there, and there are many examples listed on GitHub, and you can check all the examples of these things. Uh, when we actually go with all the stuff of Azure functions and virtual functions, and we did not discuss the KEDA functions. KEDA is actually a bridge between both of them. Like KEDA is a bridge between the event-driven autoscaler with the Azure functions and between the Kuban Artists. So if you want to have a certain process, I have tons of example in my company, in other places where you need auto scaling capability as well, but that is a single purpose lightweight component, and that is required to be auto scale on Kubernetes cluster. But I also want to reduce the cost of the customer as well, so that really helps me. So not to exaggerate on that, if in my past, in my just recent assignment a few months ago, we actually reduced the cost to more than 30 to 45% of the actual bill that we were getting using the KEDA functions and the Azure Widget function, rather than we were actually using a complete fleet of 200 plus containers and servers and schedulers and other stuff which were like 24/7 working, but in 20 to 30% of the scenarios they were actually sitting idle and doing nothing, but as a high availability part, we had to keep them up and running. With the use of KEDA, Kubernetes event-based driven autoscaler, we will be able to actually gel up our Kubernetes platform with Microsoft Azure visual functions and help us with the triggering and workflow part as well. And they are actually working very good with us. KEDA, using KEDA, you can specify the app or event or anything that you want to scale in your own way. You can scale that one up to to a serverless architecture as well. You can scale that one up to a Kubernetes cluster as well. You can scale that one up to an external party. You can scale that one up to any other thing. And the inline benefit of the whole equation is that it gives you flexible and safe option to run alongside other application and frameworks without actually giving you any issue. There are KEDA Kubernetes functions available across the board. There are lots of contributions available. Let me show you some of the functions. Uh, Let me share my screen once again. There are lots of KEDA functions available, and those KEDA functions can be used. And we can use that capability. And there is a complete GitHub repository as well. There are uh, lots of items, lots of change logs available over there. How to use a basic queue capability, basic Kafka capability, basic functions capability. There are lots of good contribution to this one, and basic hands-on exercises also available over there. So this is a complete uh, selection, namespace selection, auto-scaling selection, and everything that is required to run KEDA from upside beginning to uh, the end one. So with the help of the KEDA, you can use your application event-driven capabilities to lot more flexibility than this one. Here are some resources for the Kubernetes courses, for the interactive Kubernetes tutorials, for learning Kubernetes, for the Kubernetes community YouTube channel, for the official CNF2 channel, and for the KEDA and Kubernetes details for one of Ramit Surana guy. He's also very good in this one. So these are some very nice and decent resources for migrating your application over there to help understand what the Kubernetes and what the KEDA actually is, and how they are interactive with each other. Thank you for joining me. I'll be taking up your questions now. If you have any questions, feel free to ask.